Good morning. Okay, we're going to talk about the Pythagorean Theorem. Quick review on this. We use the Pythagorean Theorem with right triangles, so you have to have that right 90-degree angle. And the Pythagorean Theorem is a squared plus b squared equals c squared, where the a and the b are the two legs of the right triangle, and c is the hypotenuse of the right triangle. The hypotenuse is the side that's across from the 90-degree angle, and it's also the longest side in the triangle. So your two legs are a and b, and the hypotenuse is C. So let's go through a quick example. I've got this triangle. We know it's a right triangle because it has that marking for the 90 degrees. And we've got 7, 6, and then x. So this is the hypotenuse. So our x is the hypotenuse. And then we set up these. These are the legs. Doesn't matter which one is which. A and b could be different parts. So this is going to be 6 squared plus 7 squared equals x squared. All right, so as we continue to simplify this, 6 squared is 36, 7 squared is 49, and when we add those together, we get 85. So now we have 85 is equal to x squared. But we need to know just what one length of x, not x squared, is. So we're going to square root both sides, and that will make undoes the square on the x, so that is just x now. And then the square root of 85, that one doesn't reduce any further, and we can leave it as the square root of 85, or we can do the decimal approximation of 9.22, or approximately. So the hypotenuse is approximately about 9.22 units in length. Okay, so on this next one, we've got a side that's 5, a side that's 13, and a side that's x. And we need to figure out which one is the hypotenuse and which ones are the legs. So if we take a closer look, the hypotenuse is always going to be across from the 90-degree angle. So the side that's 13 has to be the hypotenuse. Okay, then these other two are going to be the legs. So we can write this out as 5 squared plus x squared is equal to 13 squared. And then we're just going to need to simplify that. So we've got 25 plus x squared is equal to 169. Now I need to get that x squared by itself. So I'm going to subtract 25 from both sides. So I've got x squared is equal to 144. And now to solve for x, we need to square root both sides. And normally we do the plus or minus because we're writing in that symbol ourselves, but we can't have a negative length, so we're only going to go with the positive 12. So this other side of the triangle has a length of 12 units. All right, so now let's go on to the trigonometry. So to solve a right triangle, once again, it has to be a right triangle. You have to have that 90 degrees, and then you need to have an angle of reference, and it doesn't matter which one it is. I'm using theta as the variable to represent this angle of reference. So if I'm standing in a triangle-shaped room, I'm standing in this corner of that room, that'll help us figure out which wall is opposite. So the side that's directly across from the angle of reference is the opposite side. The hypotenuse we've already talked about is across from the 90-degree angle, and the adjacent one is the one that helps create the angle of reference. It's the one that's right next to it. Okay. So we've already talked about in class, we've got the sine ratio, the cosine ratio, and the tangent ratio. So the sine is the opposite side over the hypotenuse, the cosine is the adjacent side over the hypotenuse, and the tangent is the opposite side over the adjacent side. Okay, and also in class we talked about using the mnemonic SOHCAHTOA. This means the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and that the tangent is the opposite over the adjacent. All right, so we're going to start with how to find the measure of an angle using sine, cosine, and tangent. Okay, so I'm asking you to find the measure of the angle theta. So before we get started on this, we have to figure out which one are we going to use. Is it going to be sine? Or is it going to be cosine? Or is it going to be tangent? And the way we choose that is from using our labeling of our sides. All right, so if we're standing where theta is at in this corner for angle A, the opposite side, or the wall that's across from it, is going to be here. So that's our opposite side. The one that's across from the 90 degrees, the 13, is the hypotenuse, and that makes 12 the adjacent. So we need to look and choose, is it going to be sine, cosine, or tangent? I've given you the 12 and the 13, so that's the adjacent and the hypotenuse. So that means that this is going to be a cosine, because it includes the adjacent and the hypotenuse. So I can write it out as the cosine of theta is equal to the adjacent side, 12, over the hypotenuse, 13. So now in order to solve for the angle theta, we need to use the inverse function. So the inverse function is the one that has a little marking as a -1, kind of like it's an exponent, but it's not the exponent. So to undo taking the cosine, we use the inverse cosine, that one with the -1, and we do it to both sides. So that will undo the cosine, and now I know what theta is. Theta is going to be equal to whatever the inverse cosine of 12 divided by 13 is. Now to do this, you'll need to have your calculator. All right, so I've got my calculator here. You can find calculators online. Even if you do the Google calculator, you just want to make sure that your setting is in degrees, not in radians. So you'll need to be in degrees. In fact, I'm going to check mine right now. And yep, mine is in radians, so I need to switch it over to degrees. Okay. And now you'll see I've got the sine, cosine, and the tangent, but right above it are the inverse functions of those. So I'm going to do the inverse function for cosine, so the inverse cosine of 12 divided by 13. Okay. And that tells me that my angle theta is about 22.6 degrees. So theta is about 22.6 degrees. And we did that by setting up our original trigonometric ratio and then taking the inverse function of both sides. All right, so we take a look at this one. Once again, we have to decide, is it going to be a sine, cosine, or tangent? So if I'm standing here on theta, the 4 is across from it, so it is opposite. And the side AB right here, that's across from the 90 degrees, so this is the hypotenuse. And then this makes the 13 adjacent. Okay. So I don't have any information about the hypotenuse. If I wanted to, I could use the Pythagorean Theorem to figure it out, but we don't need to do that. So I'm going to use the one that has the opposite side and the adjacent side involved, and that's tangent. So I can write out my trigonometric ratio as the tangent of theta is equal to the opposite side 4 over the adjacent side 13. Okay, so the opposite side 4 over the adjacent side 13. And now to solve for the angle, I'm going to use the inverse tangent. So I'm going to take the inverse tangent of both sides. And theta is equal to the inverse tangent of 4 over 13. And I'll use my calculator again to figure that out. All right, so I'm going to use the inverse tangent of 4 over 13. And that tells me that that angle is about 17.1 degrees. So my angle theta is about 17.1 degrees. Okay, now we're going to go over how to find the side, a missing side length. So we're given an angle, and that's going to be our angle of reference. Okay, so we're given the angle 37 degrees, and we're given the side 11 and the side x. We just need to label which ones they are. So if I'm standing on the 37 degrees, and that's my angle of reference, then I'll know that this side opposite here, CA, is the opposite side. It's across from it. And this side is the hypotenuse. And this side is the adjacent. So now I just need to decide which trigonometric function uses the adjacent and the hypotenuse. So once again, that's going to be cosine. So I can set this up as the cosine of 37 degrees, because I actually know the angle now, is equal to the adjacent side, 11, over the hypotenuse x. So the adjacent side 11 over the hypotenuse x. And now we just need to go through and solve this proportion. So I'm going to multiply both sides by x. Okay, so those cancel out, and now I've got x times the cosine of 37 degrees is equal to 11. Now, cosine of 37 degrees is just a number. It's an irrational number, a decimal, but it's just a number. So if I have x times a number equaling 11, I just have to divide by that number. So I'm going to divide both sides by the cosine of 37 degrees. All right, so once I divide by the cosine of 37 degrees, then that's going to give me a decimal approximation for the length of the hypotenuse side. So I'm going to go to my calculator again. And I'm not going to use the inverse one, the one that has the little negative one. I'm going to do just the regular cosine. So this is going to be 11 divided by the cosine of 37 degrees. And that tells me that the hypotenuse is approximately 13.77. Okay, so that's about 13.77 units long. All right, so for this next one, we're going to, once again, solve for a missing side length. So I've got the hypotenuse, it's across from the 90 degree. The hypotenuse is the side that's 11. And if 60 is my angle of reference, that means that this side is going to be adjacent because the side AC would be opposite from the 60 degrees. So this side is adjacent. So what uses adjacent and hypotenuse? Well, once again, that's going to be the cosine. So I can write this out as the cosine of 60 degrees is equal to the adjacent side, x, over the hypotenuse, 11. Okay, now it is just coincidence that both of these are cosine and that there happens to be the number 11 in both of them. That's just coincidence. So you really need to label your sides and then choose which trigonometric function you should be using. Okay, so but to solve this, we're going to do the same thing, multiply both sides by 11. So we're going to cancel out those 11s, and now this is going to be 11 times the cosine of 60 degrees. And I just need to type that into my calculator. So I'm going to pull my calculator over. So now it's going to be 11 times the cosine of 60 degrees. And I get 5.5. So that means that that side length, x, is exactly 5.5 units long. Okay, so let's put this into a situation. So let's say that you're standing from pretty far away from a tall building. Let's say that you are 1.5 miles away from that building, and you want to figure out how tall that building is, and you take out your clinometer, and you know that the angle that it creates is 2 degrees. Really, really small. So a really small angle because you're standing really far away. And you want to know how tall this is in feet. So one thing that you will have to remember is that for 1 mile, it's 5,280 feet. Okay, so every mile is equal to 5,280 feet. So instead of doing this in miles, I want to convert 1.5 miles into feet. So I'm going to do 1.5 times 5,280, and then that'll tell me that it's going to be 7,920 feet that you're standing away from the building. Now that my units in this are measured in feet, that'll tell me the height of the building in feet. All right, so as we take a closer look at this, we're asking you to find the height of the building. This is our x. We know this side, and I'm asking you to figure out how tall the building is, and you know that this angle of elevation is 2. So this is going to be tangent, because this is the opposite side, and this is the adjacent side. So it's going to be the tangent of 2 degrees is equal to the opposite side, x, over the adjacent side, 7,920 feet. Okay. So to solve this, I just need to multiply both sides by 7,920. So 7,920 feet multiplied on both sides. Okay. So 7,920 multiplied on both sides, that's going to reduce out. So x is going to be equal to whatever 7,920 times the tangent of 2 degrees. So this is where I'm going to need my calculator. All right, so I'm going to do the 7,920, and I'm going to multiply that by the tangent of 2 degrees. So that tells me that the height of the building is approximately 276.57, and my units are in feet. And that's a tall building, but that's not astronomical. It kind of fits with the situation. So you want to take a look at your units and make sure that your answer makes sense. Okay, so if we look at this, if I'm standing 1.5 miles away, and I use the tangent, and I figured out that that building is 276.57 feet tall.